8162. Between each row of rotating blades in a turbine engine compressor, there is a row of stationary blades which act to diffuse the air. These stationary blades are called A. Buckets, B. Rotors, C. Stators. The correct answer is C. Between each row of rotating blades in a turbine engine compressor, there is a row of stationary blades that act to diffuse the air. These stationary blades are called stators. The stators are an essential component of the compressor section in a turbine engine. They are fixed in position and serve several purposes, diffusing the airflow. The stator blades are designed to diffuse the high-velocity airflow exiting the previous row of rotating blades. They help to slow down and redirect the airflow before it enters the next row of rotating blades. This diffusion process ensures a smoother flow and optimizes the efficiency of the compressor. Guiding the airflow, the stators also act as guide vanes, directing the airflow at the appropriate angle into the next row of rotating blades. They help to control and manage the airflow direction to maximize the efficiency of the compressor. Maintaining pressure and velocity. By diffusing and guiding the airflow, the stators contribute to maintaining the pressure and velocity of the air as it passes through the compressor. This ensures that the rotating blades receive a steady and optimized airflow for effective compression. 8163. Standard sea level pressure is A. 29, B. 29, C. 29.92 inches of Hg. The correct answer is C. Standard sea level pressure is commonly expressed as 29.92 inches of mercury, inHg, or 1013.25 millibars, MB. This pressure value represents the average atmospheric pressure at sea level under standard atmospheric conditions. In aviation and meteorology, the standard sea level pressure of 29.92 inch Hg is often used as a reference for altitude measurements and atmospheric pressure differentials. It provides a baseline for comparing pressure values at different altitudes and locations. 8164. Using standard atmospheric conditions, the standard sea level temperature is A. 59 degrees Fahrenheit, B. 59 degrees Celsius, C. 29 degrees Celsius. The correct answer is A. Using standard atmospheric conditions, the standard sea level temperature is commonly accepted as 59 degrees Fahrenheit, 15 degrees Celsius. This temperature is used as a reference point for various calculations and measurements in aviation, meteorology, and other fields. Standard atmospheric conditions define the average temperature, pressure, and density at sea level under standard conditions. The standard sea level temperature of 59 degrees Fahrenheit is widely recognized and used as a baseline for temperature comparisons. 8165. When aircraft turbine blades are subjected to excessive neat stress, what type of failures would you expect? A. Bending and torsion, B. Torsion and tension, C. Stress rupture. The correct answer is C. When aircraft turbine blades are subjected to excessive neat stress, stress rupture is the type of failure that can be expected. Stress rupture refers to the failure of a material under prolonged exposure to high levels of stress. In the case of turbine blades, they are subjected to significant mechanical and thermal stresses during engine operation. These stresses include centrifugal forces, high temperatures, and cyclic loading. When turbine blades experience excessive stress beyond their design limits, it can lead to stress rupture failure. This failure occurs when the material of the blade undergoes progressive damage and eventually fractures under the applied stress. Stress rupture failures typically occur over time, with the material deforming and weakening until it reaches a critical point of failure. 8166. In an axial-flow compressor, one purpose of the stator vanes at the discharge end of the compressor is to A. Straighten the airflow and eliminate turbulence, B. Increase the velocity and prevent swirling and eddying, C. Decrease the velocity, prevent swirling, and decrease pressure. The correct answer is A. In an axial flow compressor, one purpose of the stator vanes at the discharge end of the compressor is to straighten the airflow and eliminate turbulence. The stator vanes are stationary blades that are positioned between the rotating blades or rotor stages of the compressor. As the air passes through the rotating blades, it may become somewhat distorted or turbulent. The stator vanes help to rectify this by redirecting the airflow and ensuring that it flows in a more uniform and straight path. The stator vanes straighten out the airflow by removing or reducing any swirling or eddying motions. By straightening the airflow, the stator vanes contribute to improving the efficiency and performance of the compressor. They help to reduce energy losses due to turbulence and ensure that the compressed air flows smoothly into the next stage or component of the engine.